Okay, hi everyone, and welcome to our virtual road trip webinar series. I'm Molly Soltis with Asphalt Testing Solutions and Engineering, and it's my pleasure to welcome you to today's trip, which is focusing on the importance of QC and QA. We're joined by two industry experts who will discuss why quality control and quality assurance are so important in the lab. But before I introduce them, let's go over a few housekeeping items. The attendee controls appear at the bottom of your screen. In the bottom left-hand corner, you will find the audio settings. You can adjust your speaker settings here. Since you're a webinar attendee, you will be in listen-only mode. If you have an issue with the sound, exit the webinar and rejoin. Moving to the right at the bottom of your screen, you will see the raise hand icon. If you have an issue with, you can use this if you need something from the host. And if you have a question, please use the Q&A window. Open this window and type in your question. We will address questions at the end of the webinar. Now I'd like to introduce you to today's speakers. Rhonda Hale has worked in the industry for 22 years, focusing primarily on asphalt production and testing. She spent the majority of her career with the Florida Department of Transportation, and she is currently the lab manager at ATS in Jacksonville, Florida, where she manages the 3 QC labs. Dr. Mary Stroup-Gardiner has been conducting and publishing asphalt pavement research for almost 40 years. She has been active in the development of field and laboratory test methods, guidelines, and practices through her work with the ASTM D4 Committee on Road and Paving Materials. Mary currently works through Gardner Technical Services in Monterey, California. Now, thank you for choosing ATS as your trip provider today. We know you have many options when it comes to travel and webinars, and we greatly appreciate your business. Now we invite you to sit back, relax, learn, and enjoy your trip.
Hi, everyone. Thank you for joining us today on our little trip. We're going to start out with some quality assurance discussion.
So quality assurance is another aspect of that quality system that everybody's aware of that we have to work under. I've wrote some things down here on our slide, talks about how quality assurance and quality control go hand in hand, that they are two of very important aspects of the quality system. There are quality assurance activities and responsibilities that cover all of the quality system in one fashion or another, but QC is a subset of the QA activities. So this chart is something I put together that talks about how QC versus QA, where with quality control, you've got the product, you've got the asphalt that we're testing, and then on the QA side, you've got that process, that oversight. And it's more on the QC side, you're reactive. You're going to tweak that mix. You're going to find out what's going on if there's a problem. Where on the quality assurance, you want to be proactive. You want to try to head off those problems before they happen. Again, quality control, it's a testing function. You've got your technicians in the lab. You've got them running tests. Quality assurance, it's more of an overall staff function. Everybody wants to make sure that the testing is done the same way, that you're being consistent, as you're getting more consistent results if everyone's doing things the same way. Again, quality control, you're going to find the defects. If there's a problem in the plant, something goes haywire, during that testing period on that quality control, you're going to find that defect immediately. Quality assurance, you're looking at putting processes in place to prevent those defects from happening. What is quality assurance and why is it important? Well, quality assurance, it's a big overall picture that focuses on providing the confidence and the quality for your customers. You want to make sure that you have everything in place that you can, for your customers to say, you know what, I'm going to go with that company because they're giving me everything I asked for and they're doing it in a timely fashion. And they've got the processes in place to show me that they can do a good job. So in a nutshell, it's me telling my customers that I'm going to deliver on the promises and I'm going to satisfy them across the board with the goods and services that I promised them. So why is it important? It's important because that's how we get business. It builds trust in the market, consistency, word of mouth. So it makes us competitive, and it makes us, it makes you and us to whoever, you know, if you build that quality assurance and you build that customer relationship, then you're going to want, the people are going to come back to you every time. So that's why it's so important. And I lost my mouse. There we go. All right. For us here in the state of Florida, we do a lot of work with the Florida Department of Transportation. And a lot of the quality assurance is a cooperative effort through the Florida Department of Transportation, the FHWA, which is the Federal Highway Administration, and industry, which is the asphalt plants. So quality assurance for construction projects has these main 6 parts in it. And that's when we work with the department, and I've gotten way ahead of myself. I didn't flip my little notes. But so we work with the department to incorporate these items for quality assurance. So you've got your contractor quality control, you've got your verification, you've got resolution, you've got independent assurance, and then on that quality assurance side that's very important is your laboratory qualification and your personnel technician qualification. The Code of Federal Regulation is very important, and that's what the department plays off of through the FHWA. And there's a lot of elements embodied in that, and there is a website, an electronic Code of Federal Regulations that you can go to actually look up this entire code and read through it. But that is where the quality assurance program is pulled from for the Department of Transportation. So that's why they mandate that all testing be done by qualified personnel through the quality assurance program. That's why all laboratories are mandated to be accredited by accredited bodies like CMEC or AASHTO Resource. And that's why all the materials placed into department projects have to be validated or verified. And there has to be a resolution process defined if you have defective materials. So all of those things are part of that quality assurance program. Another thing that is built upon with the department is partnering. And there are core elements in this quality assurance program that help us, and it's kind of compared to the structural elements in a bridge. You've got your contractor quality control on one side, you've got the FDOT verification on the other side, and all of those things in the middle, which are quality assurance, your personnel qualification, your laboratory accreditation, your independent assurance and resolution processes, all of those things in the middle, those help build that partnering process between the contractor and the FDOT to make sure that the material that's being placed on the road, the service that you're giving the department is what they want, you're giving them the best that you can give them. So that develops a very good partnering process by laying all of these things out there together and grouping them together. So why is QA important to me? Well, quality assurance is important to me because part of it is that QC, that quality control, it requires good teamwork. You've got to have good organization. You've got to have some guided task and meaningful completion to get good results. It always gives you a leg to stand on. We have a lot of building this company. We've kind of built things from the ground up. We've put our labs together. We're in the process of completing a brand new lab now. And without that quality assurance process, I wouldn't have the guidance that I needed to get that, to know where I needed to go. So that quality assurance tells me I need this type of equipment, and I need this equipment calibrated at these intervals, and I need to have it accredited so that I can, in turn, work for the department. So all of those things give me the guidance in it enables me to do the job to the best of my ability by following these quality assurance guidelines. So there's many times that I fall back on my guidance of, I'm a very organized, and I look for the guidance in the black and white to be able to do the job that I do. So for me, the guidance in these manuals and things like that are very helpful. It gives you a place to go back to, and it gives you a jumping off point. I'm not saying that everything is going to be exactly the same every time, but it does give you a place to go to start that organization to help do things in the way that they should be done so that you can get where you need to be able to do those jobs and to promise your customers that, yeah, I'm accredited. We've done everything by the book. We've got all of our T's crossed, all of our I's dotted, and we have the best technicians there are because we've sent them to all of the training that's required. We keep them trained. They have annual reviews, and so we keep everything up to date. We keep everything, and we have our manuals and documentation to prove it. So that's why QA is important to me, because someone questions me or a customer questions our integrity or the job that we're doing, I can say, oh no, we have it. We keep up with it. We have all of our paperwork right here. We're good to go. And we're going to do everything right, and we're going to do it the best that it can be done. So that's why it's important to me. It's just that leg that we can stand on, and it's our backup documentation to prove that we're good at what we do, and we're always going to do the best that we can do to deliver that process and that service to our customer. So now I think we're just going to move right on into Ms. Mary's presentation.
Rhonda just told you how you do and how it's important to make sure everybody's on the same page. And I'm going to give you a little idea of where to look and what's going on when those results between your QC and your QA just don't match. Okay, Rhonda started with this nice concentric circles, everything's lined up. Sometimes quality assurance moves a little statistically one way and your quality control moves the other. It's not quite enough to throw all of your results, into a default setting or out of spec material, but it's enough that, as statistics says, if you keep going, you're going to be in trouble because you are statistically sooner or later going to be out, and it's not going to be because your material is out. Where do you look for problems when this happens? Well, the starting point when QC doesn't match QA, I mean, the first obvious thing people think of, material doesn't meet specs, or the test method isn't performed correctly. That should be the end point, not the starting point. You need to look at your between lab testing variability. And the big things that really impact that testing variability are going to be the time between sampling and testing. When did you grab those split samples? When did you split them? How long did they stay in the containers? How did you handle them? Were they left in the back of the truck all day in the sun? Did you stick them someplace where it gets frozen overnight? What are your reheating protocols? How do your technicians, even within the lab, handle these differences in material? I mean, does everybody split the sample, roll the sample, prep the materials? Big problem. Can be very small differences can have a statistically significant effect. And then once you get out of the testing, we use a few test methods and the results from those to calculate a lot of variables. And we think because we're calculating the values, we don't think of calculated values as actually having a mathematical variability, and they do. And those calculated values of variability of the values are not well established. And in coming up with the math to figure out what they actually should be, the math is painful. I'm going to pick on Florida because I got a lot of data from a bunch of projects out from another research I was working on. Got 14 projects from 2017, 2018. The average duration of the project was 3.5 months, over 1,000 QC data points and over 100 pairs of QC verification testing points. I think maybe 2 sets of the QCVT samples were out of spec, but there were several projects of these 14 that had statistically different values on the material properties they were measuring. Materials unmodified 5228, a modified 7622, 2 types of mixes, a 12.5 and a 9.5 super pave mixes. Generally, most of the projects had around between 20 and, well, 24%, because everybody's trying standard 25 on the wrap. Heating protocols, I'm picking on Florida because they have a rather unique way of doing their QC and VT testing. It's done in the same lab. In other words, the verification testing is done in the contractor's lab. Same equipment, same everything, except different technicians and, of course, different timing. QC is, they grab the samples out of the truck, split them, you know, half for QC, half for verification testing. QC samples are reheated for an hour and at the compaction temperature. Verification samples are reheated for 1.5 hours, remixed, reduced to testing size, and reheated for another hour more. So same lab, different technicians, different heating standards, and you can get statistically different values for split samples in the same lab for the same project. And what's going on? This is an example of what happens with QC and your verification. On the y-axis, QC on the x-axis, you can see that everything's below this line of equality. This everything, if everything were as it should, all of these nice little orange squares should be sitting on this line, and they're not. Your QC densities are higher consistently, statistically significantly different and higher than your verification testing. And what's going on? Again, this is the polymer modified. Possible causes. Obviously, for some reason, the QC samples are easier to densify. Is that because we're compacting them very quickly? And the verification, especially with the polymer modifieds, they're sitting in a bucket, a little harder to maneuver. It's not going to be those typical things we go to with equipment differences. We know that it's the, sorry about the phone in the back. I thought I got rid of it, but obviously not. Welcome to home office. The equipment's the same. You don't have to worry about angle of gyration, types of compactors, compaction equipment, whatever's going on. It's all the same. The only thing that's different is the material and storage handling. They're split samples, so the material variability is going to be very low between QC and VT. It's going to be down to differences in the technician technique, that style, that thing when we try to write standards, having done this with ASTM for almost 40 years, trying to explain technique, how you pick up a handle, how a sample, how you handle it, how you get it in the oven, how you measure the temperature. It's very hard to put that into a written description. Technique makes a difference. It's possible that maybe the difference in storage times and the longer reheat times for the different samples is making a point. I don't have enough data to know, but I know where I need to look. Polymer modified asphalts are normally stickier and stiffer. They're harder to maneuver. Maybe that's causing a problem with maybe not quite getting the densification that we want. Just sort of like I said, might not be workable. The unmodified mixes, now all of a sudden we see a statistically different shift up. The VT samples, the verification samples, are getting higher densities than the QC samples. This might be a function of, again, material storage and sampling. The verification samples are heated for an hour and a half longer. Maybe that asphalt's getting really, the viscosity is getting lower than it would be in the QC samples, so it's going to be easier to compact. It might be making a difference. Again, the viscosity temperature relationship, and it's going to be different than the polymer modified, and it's going to be easier to get a more fluid response for longer reheat times. Maybe we should be, and this is one of those ASTM questions that we need to ask. That's not gonna, you're not gonna find it in the standard yet. Maybe we should be measuring the mix temperature rather than just specifying the hours in an oven. Some agencies do say, you know, bring it up to compaction temperature, then do it. So pay attention. Again, differences in that technique, that style, that how you handle it, how you place it, how you spread it in the pan, it's gonna make a difference. Now let's take a look at maximum specific gravity. When your maximum specific gravities are statistically significantly different, again, this is a polymer modified. These lines, your QC max gravities are higher than your verification testing. What's going on? You need to focus on specific gravity. The generic thing about specific gravities, regardless of whether it's aggregate, asphalt, mix, wrap, whatever, it's a relationship between a mass and a volume. If, let's get down here, if the mass and volume ratio is different in the you know, in your values or in your specific gravities, you have to stop and think about it. Is the mass going to be the likely place where the difference happens? No, because technicians, I don't care where you are, a technician can measure 1,500 to 2,000 grams of mix and put it in a pan. So the mass is going to be the same. You might, you know, get a little bit of difference if you're not handling your split right and getting a little bit of segregation going on there. That might make a difference of what's in the mass, whether it's aggregate or asphalt, that might change. But the volume is going to be your biggest place where your differences are going to be showing up. And it's going to have to do between maybe longer times between testing. Maybe it sat, your verification samples sat in the bucket for a couple of days longer, especially if it's polymer modified, it stuff sticks together. Different times in the oven to get the mix workable. That's one of those English words. You know, how do we define workable? Well, workable comes under that thing what I was saying about technique. What can we agree on is workable, and it's going to be consistent within a lab, but it's going to vary between labs because everybody's going to have that different style. What happens when we're doing maximum specific gravity, we're getting the volume of individual asphalt coated aggregate particles. We're measuring the specific gravity of the volume of these little gray and black circles. Particles are separated thoroughly. It's easier to do with unmodifieds. When particles are not well separated, when we don't spend that time getting our max gravity, especially with polymer modifieds, I'm going to pick on polymer modified, it's hard to break up those individual aggregate particles, especially the fines. You're always going to end up with little trapped air voids between groups of particles. And those little trapped air voids seen here as those red spots are going to end up being included in the volume. So in this little equation over here, your mass is constant, whether you've got perfectly separated particles or groups of clumps of materials over here. 2,000 grams of mix is 2,000 grams of mix. The difference is going to be in this volume. You increase this volume, you decrease specific gravity, and your max gravity decreases. That causes that statistical shift. Unmodified max gravities, now the verification samples have a higher specific gravity than the QC samples. Well, what's going on with that? because it's easier to get your individual particles separated with unmodified asphalts. They just don't have that sticky, gluey feel to them. What happens is your aggregates immediately after mixing, you've got that nice coating on your aggregate particles, but because it's got a higher viscosity, it doesn't intrude in these little white areas, those surface voids on your aggregate. That's immediately after mixing. So the volume of around this black border circumference is going to be bigger than it is over here after that mix has sat in a bucket or gotten heated again. This asphalt on the surface has time to intrude further into these water permeable or asphalt permeable voids, and therefore the asphalt, there's less asphalt on the surface of the aggregate, more into the pores. So the volume of this black border is smaller. So the volume decreases. So that is going to mess with your maximum specific gravity. Absorption is, it has to do with viscosity and the pore size of your aggregates, whether they have a high water absorption capacity. That really accentuates the problem. Time. These are things that are governed by physics, and we can slow them down by keeping them at cold temperatures, but it's still going to happen. So if you want to keep your materials as constant as possible, you have to keep your time short between testing and storage and sampling. You have to be very careful about your heat histories, because you can easily adjust or bias your test results by how you're handling. And in this case, the way this is going, if the asphalt is absorbing into your aggregate, your max gravity is going to increase. And since we use calculated values to do our air voids, we use bulk and max gravity air voids, you get slight statistical differences in either one or both of those values. You're going to place games with your air voids, and your air voids are going to come in and out of spec. VMA is another one of those calculations. Some agencies use VMA specs. That's a calculated value. Just because we use a mathematical equation to get a value doesn't make it any more precise. Voids filled with asphalt, another one of those things. We need the percent binder absorbed, the effective specific gravity, and the percent effective binder to get down to your dust proportions. Now, a lot of these are more of a function of your mix design than your QC, QA stuff, but there are times people are monitoring dust proportions as you're going through production. I've seen some people monitoring voids filled with asphalt. What happens? This is air voids, again, going back to your polymer modified. You can easily get above that line of equality. Now, in this case, like I said, all of these data were within spec, but you can see if you look at this, there's leanings one way or the other for statistically significant differences. Now, while those differences aren't throwing the values out of spec, sooner or later, you're going to get a mix or a project where these values skew just slightly more or up or down, and now you're going to have problems meeting your air voids requirements. And that has nothing to do with the quality of the material. It has nothing to do with whether or not you're getting the product you wanted as a client. It has to do with the differences between the laboratories, that technique, that handling, those things that we really do a bad job of detailing down to the finest detail to get everybody doing the same thing. Calculated voids. Now, air voids, it's probably the only calculated value that we actually have a test method that says, here's an equation that you can calculate your standard deviation of your air voids. This is the equation for the standard deviation for air voids. It is ugly. It is a value of your mean max gravity, the standard deviation of your bulk gravity, see the X and the Y, and then you flip-flop for this one divided by your mean down here. This is a very complicated equation. It's mathematically correct, and it is derived from a process called propagation of errors. You put two test methods together to calculate something else, and the variability from each of those test methods propagate the errors. This is very important. Let's take a look at what we do. We do them without thinking. We put them into spreadsheets. They spit out numbers. But how are these things related? Your bulk and your max gravity are used to calculate air voids. Asphalt and bulk to get VMA. VMA and air voids to get our voids filled. In other words, 3 test results, 2 calculated values to get a third value. Propagation of errors. Every time you add something, you're increasing the error. Going the other way. Come on, there we go. Effective specific gravities. You now have 2 test results, and these guys over here in blue are their test results, but when we start production, they become constants. I mean, we're not changing them, you know, every day. We're not doing bulk specific gravities on our binder or bulk specific gravities on our each individual aggregate stockpile. These are relatively constant, and small changes have a minimal effect. So they're in blue, they're test results, but they're sort of constants. Your percent binder absorbed. Look at how we're starting. We started off with these 3 tests. You got asphalt, bulk, and max gravity, and you're starting all of these calculated values. Look at those equations. Propagation of errors. You get up here to dust proportions, and you have a 4th test percent, your P200 down here, and all of these calculations going into that. Propagation of errors. Calculated variability. How do you get variability for these calculations? Well, you can do the painful interlab round robin. You can use the mathematics to develop the variability equations for each of those. Been there, done that. It ain't pretty. Painful is a polite way of saying don't go there. The easiest way is to control the variability of the actual results that you use for the calculations. And you do that by going backwards in this flow chart. You take out the calculations. You work your way back to the test results. You work down, you get rid of that. You notice that as I keep going, the only thing that's staying here is the blue semi-constant for a project. And we've got 4 green test results. We get rid of all of these down here for the calculated values. And the only thing that is going to play with the variability of all of those calculated values are these 4 test results and these 2, once production starts, semi-constant values. So if you have things that are going out of whack and they're a calculated value, you need to get back to basics. These 4 tests, take a look at what's going on. Control those variabilities, and you can control your calculated values. I'd love to be able to consider QCVT plots as another form of control chart, but you only get a good picture of what's going on at the end of the project, so they're not really a control chart. They're a great forensic evaluation tool. Factors that influence agreement between labs. Storage time. Pay attention to when you sample, where you sample, how you store it, how long you store it, the temperature conditions that you're doing. If you don't have something in your specifications that limit your times for handling things, make sure that you're doing them consistently, and not only within lab, but between lab. Talk to your other labs. Make sure that everybody's got that same style, that technique. They're going down They're doing everything consistent. Again, sample preparation. How are you splitting your samples? How do you mix them before you split? When do you mix them before you split? Control variabilities in your calculated values by controlling you got 4 test results. Pay attention to those. Spend your time with those. Do them right. Actual test results, calculated values. If you got to use them, just understand that they have a variability, and that variability is defined by the propagation of errors. And errors are like bunny rabbits. You put 2 together and you're going to get more errors. So stay with the basics on that. And with that, I'll turn it back over to Molly for any questions. Whoops, wait a second. I think I got one more. Oh yeah, this was just for me, because I really don't like doing forensic analysis. I mean, I do forensic analysis, but I'd rather not have to. It's just sort of reinforcing. Be consistent. Keep everything as consistent. Specs don't define, sometimes they don't. Make sure you're measuring your mix temperature. Only heat until desired. Don't let that absorption take place, so you're messing with your max gravities. And get those particles separated on your max gravity test. It's so crucial for getting consistent results. Okay, now I have a question slide. So I'll turn that back over to Molly.
Okay, folks. I think we do have. That's okay. Hey, Molly, Rhonda, we're all the same. We'll just roll it. We'll just keep it rolling.
Whoever's got their mic on, go for it, guys.
Yeah, that's right, because we've had some technical difficulties for sure. So we've got a few questions down here, it looks like. Let's see what we got. From Mr. Steve McReynolds. This one's for you, Miss Mary.
Oh, dear.
You mentioned a difference in technician technique.
Oh, yeah.
Can you elaborate on this factor, and how do you minimize it, especially if the methods are being followed and it's just the style of the technician? What more are we supposed to do to prevent this from becoming the difference between pass or fail?
We've always known this is a problem. At ASTM about 5 years ago, we decided to do videos. We wanted to see if we could put videos in with the test methods to see if, that would, help with some of that technique. And we got a premium national laboratory to host a video. We were doing an emulsion testing. We just wanted to see something simple that had more words like technique descriptions rather than, machine drawings and what have you. And we got somebody to oversee the filming from a company that designs and manufactures emulsions. And they did it, and we were so proud of it. We showed it the other half of exec, and the other half of exec just ripped us and said, why didn't you get a lab that knew what they were doing? They were doing it all wrong. And we just dropped our mouths. And when we told them who hosted and who directed, they dropped their mouths. At that point, we realized we have a problem in getting back to getting that technique out of impacting our test results. It's almost like we really do need videos, or, if I'd like to say in person, where you share your technique with people. In other words, we share everything online in these days, but it would be really nice if we could, in our lab, we do this. This is how we split our sample. This is how we interpret those words. How do you interpret? And how can we get consistent? It's almost like we need a pre-lab meeting to go along with our pre-construction meeting, so everybody's handling materials in the same way, in the same form for every project. Maybe, things change as they go on, but it's almost like we need some way of getting everybody there. And I wish I had an answer rather than this long rambling discussion, but it's it's something we have been struggling in more and more with. How do we use the English language or any language to describe these types of laboratories?
You're right, the small discrepancies between technicians. I mean, we have it here, and the older technicians have their way of doing it. You hire new people, and you're trying to train them, and the older technicians say, well, just do it this way because this is the way I've always done it. Might not be exactly the way, you know, the test method shows, but you need that consistency. You do need that consistency across the board. But everybody has their own little idiosyncrasies when it comes to doing their testing. And I think what Steve was trying to say was, how do you can't, I guess there's no way to totally eliminate that. So
No.
I don't know what the best answer is to see, to how to minimize it, you know, without basically, as a lab manager, me becoming a czar, standing over each of them and saying, you're not doing that right. You know, I'm watching each one of you and you are not being consistent across the board. I don't think that's feasible either, you know.
No.
But I understand about the consistency because I'm a big proponent of consistency myself. So I totally understand what you say, but I don't know that answered Steve's question or not. So I don't know. I think the last part of his question was, what more could we do to prevent this from becoming a difference between pass or fail? So
the difference between pass or, that's why I said it's almost like if you have something of a chance to just either go back and look at your QCVT, do those plots for several projects and see how things are lining up. Do they line up for a particular set? You know, you have a verification lab and a contractor lab. Are there a particular set of labs that are consistently running slightly up or slightly down? Then you might want to go take a look at that. It's almost like you have to do a proactive forensic evaluation to see where you are. I mean, those graphs I showed show the labs, each lab, I mean, everything is pretty parallel on that line of equality. It just slips up or down a little bit, you know, not enough to throw it out statistically, but they are statistically different and they will eventually go out one way or the other. So it's almost like, you know, plot these results as you're going to see where they're falling on that line of equity, you know, the line of equality, so that you can see if, you know, maybe five pairs of data in, they're all showing up below the line. Then you might want to go, maybe we should go, you know, check our times between sampling. How are we handling things? That might give you a little bit of a heads up that you're going to start having problems or potential problems down the line.
I know we spoke about breaking up the material when we're doing our rice test. You know, some folks break it up, are very meticulous about breaking that up. Some folks are not. And you feel like that could make a really big difference in that part of the testing.
Yeah, sometimes you're in a hurry, especially those polymer modifieds. I remember too many years in the lab trying to break those things up. My hand got calluses trying to, you know, rub those particles apart and, you know, work them apart and, you know, handle it. They're sticky and, you know, you run out of time. You got a timer going off over your shoulder. You got to go grab a viscosity test. Something's going on. So you're sometimes you short your prep. And
rush. Right.
You can't dodge that.
Gotcha. Okay. Well, let's move on to the next question here. Mr. Doug Zuberer says, Mary, good seeing you after all these years. Any experience looking at film thickness with GTR?
Run that by again. You started, I got a crackle on that one.
He said, Mr. Zuberer said, do you have any experience looking at film thickness with GTR?
GTR. Run that. Define GTR for me. On my brain just doesn't have enough coffee.
Ground tire rubber is the only thing I can think
Oh,
of.
gotcha.
Off the top of my head.
Gotcha. Okay.
Something?
Ground tire rubber. It's gonna. Oh, that's gonna take me back a few years. It comes under the heading of a polymer modified. It depends on how well, and this is a non-chemistry term, how well the tire rubber's been digested, how fine a grind it was in there, how well it's distributed in the binder. If it's well distributed in the asphalt, it's just like another polymer modified asphalt. It's just sticky, and it's hard to get those little, especially in your finer mixes, it's hard to get, the particles apart. I haven't specifically looked at ground tire, the differences between polymer modified and tire rubber, but it all handles like a polymer modified. And hi, Doug.
Okay.
It's been a while.
Our next question is, you mentioned that labs must be qualified by state DOTs. Do they require any national certs or accreditations to test contractors' mixes? Well, the labs have to be qualified by state DOTs. I say qualified is probably a good term because they come in, they inspect them, and they look at them. And labs have to have accreditations to be able to test for state projects. And so, yes, they do need to have their accreditations by CMEC or AASHTO resource to be able to run to state projects and to test contract mixes. Does that answer your question, Mr. Webster? If not, you can send me another one. And then Steve said, Florida only compares with 4 test results, as you mentioned, between QC and VT. If the between lab variability meets, the material is verified. VT results for volumetrics are not considered. I think he was referencing the information you had in your slide.
Yeah, I work with a lot of agencies, and we've done a lot of agencies over the time where the voids are the incentive disincentive issue. So that it depends on your agency what they're controlling on. I've seen some actually monitor dust proportion for their during production, which sort of makes me a little twitchy. Other ones want to control voids, your BMA. So it's agency dependent, and if that's all Florida's controlling on, then they've got a real good handle, which is why I think only 2 test results out of 1,000 pairs were out of spec that needed a retest. So I mean, Florida's got it nailed for what they're doing, and that verification testing in the same lab as the contractor cuts out a lot of the sources of potential variability.
Right. I think that's the biggest reason they went with that. You do still have the technician variability, and that does play into it significantly, because a lot of times the verification technicians are, how we say, greener, less experienced technicians. So sometimes we get a little twitchy if we have a new verification technician that comes in to verify material when we know they're not as experienced with the testing. But that goes back to the consistency of performing the test. So we always try to be around to answer questions if they have questions, and especially with the equipment, because they are in our labs. So if there's a particular way that the equipment runs or something that the equipment does, then we're always hands-on to answer questions regarding the equipment so that they know how to use that equipment properly.
Yeah, well, and that data I showed was Florida data. So you're getting those ones that were statistically significantly different were from those Florida, from the Florida sets of
Right.
testing. So it's just enough to throw it out legitimately statistically, but it's not enough to kick it out based on their tolerance ranges for what they've got those set up. So no matter how hard you try and do it and standardize it, you can shift it. Okay, on to next
Molly,
question.
do we have any more questions, Ms. Molly?
No, I think that wraps it up. So thank you so much, Mary. Thank you, Rhonda, for the great presentation and great discussion that you guys provided today. And thanks to all of you watching remotely. We hope you found value in this presentation and conversation. A recorded version will be made available, so you can watch for that. And that wraps things up. Have a great day.
Okay, bye.